Today we're going to talk about sums and differences of decimals. Take a look at this addition problem. 25 and 3/10 plus 376 and 77 hundredths. How do we add this? First, we're going to be using a lot of vocabulary today, and one of those words will be add-ins. The add-in is always one of the numbers that is being added to another number to get a sum. To solve this, we could change these fractions into decimals. So let's start with 25 3/10. What is that? 25 and 3/10. Oh wait, I just said it out loud. 25 and 3/10. I know how to write that. Here's 25 and 3/10. I have a 3 in the tenths place. That was easy. What about the other number? 376 and 77 hundredths. What would that be as a decimal? Wait, 77 hundredths? I know what that is as a decimal. 376 and 77 hundredths is 376 and 77 in the hundredths place. So there we go. And now we just need to add them. To add decimals, just like any other numbers, we need to make sure that the place values are the same, the ones with the ones and the tens with the tens, etc. And so, I notice that I have a hundredth in one of my numbers, and I don't have a hundredth in the other, but that's okay. I line it up with that nothing. I line up my tenths with my tenths, and my ones with my ones, and so on. And then I start my adding. What's 7 hundredths plus no hundredths? 7 hundredths. What about my tenths? 7 tenths plus 3/10. That's equal to 10 tenths. And so I can write 10 like this. Now I'm putting that 1 over in the ones place because look, I still have 10 tenths. Can you see it? But this helps me with my ones because now I have that extra 1. 10 groups of tenths is equal to 1 1. So I have 6 ones and 5 ones and that 1 1 that we just added. And so altogether I have 12 ones, and I can write it like this. Can you see the 12 ones? Now notice that yes, my 1 digit of my 12 is in my tens place. Why? Because it's 10 ones, and 10 ones is 1 10, and 10 tens is 100, and 10 hundreds is 1,000, and on we go. Every time we have a group of 10 in any place value, we can always move it to the left. So, now dealing with my tens, I have 7 of them, I have 2 of them, and I have that one new one that I placed there. That's equal to 10. 10 tens. Now again, I can write my 10 like this, because I can see my 10 tens, but I also recognize that that one digit of my 10 is a group of 10 tens, which is equal to hundreds. And so now dealing with my hundreds, I have 3 of them, plus the one that I just added, that 10 group of 10. 3 tens and 1 10 is equal to 4 tens, and so I have an answer or a sum of these add-ins, which is 402 decimal and 7 hundredths. Now I said there were 2 different ways we could add these mixed numbers. The first way was to turn them into decimals. This second way is to turn them into improper fractions. So 25 and 3/10 would look something like this. How would I turn 25 into tenths? Well, I multiply 10 to the denominator, since there's only a 1 there, and 10 times the numerator, which is 25, so I'd have 250 tenths plus those 3/10, which would equal 253 tenths. Now, what about the 376 and 77 hundredths? Because it's out of hundredths, I could simply multiply 376 by 100, as well as its denominator, which happens to be 1, by 100 as well, and end up with 376 hundredths, or 37,600 hundredths. But we also have those 77 hundredths, so what do we do with that? Yeah, put it together, hundredths and hundredths, and we end up with 37,677 hundredths. Now, in order for us to add this 253 tenths to our hundredths, we need to make them both either hundredths or tenths or something that's in common. In this case, I'm going to go with hundredths because I know 10 times 10 equals 100. So I'm going to multiply my denominator by 10 and my numerator by 10. And now I have 2,530 hundredths plus 37,677 hundredths. And putting them together gives me 40,207 hundredths. But I want to write this as a decimal. And so, what is 40,207 hundredths? Oh, I just take 40,207 and put it so that it ends in the hundredths place. Like this. Can you still see that 40,207 and how it ends in the hundredths place? Well, what's this new number? 402 and 7 hundredths, which is equivalent to 40,207 hundredths. I guess the question you need to ask yourself now is, which route did you prefer? Which method of solving this was better? Remember, we did it two different ways. We did this way, where we took the mixed numbers and turned them into decimals and then added them. And then we tried it another way, where we took the mixed numbers and we turned them into improper fractions and then added them. So think about that as we try this next problem. So here's the new problem, 426 and a fifth minus 275 and a half. Now again, let's try this two different ways and see which one you prefer. First, let's turn these into decimals. So 426 and a fifth, what would that be as a decimal? Well, we know what the whole is, 426. But what do we do with that fifth? Oh, a fifth. We can do what we did in the percent lessons, where we take a fraction and we multiply it by a number to get either tenths or hundredths, and then we know what the decimal is. So how do we make a fifth into a tenth? We simply multiply 1/5 by 2 over 2. Because 1/5 times 2 over 2 gives us 2 tenths. Oh, wait a minute, 2 tenths. That's a decimal. I can put a 2 in the tenths place. And so, 426 and 1/5, written as a decimal, is 426 and 2 tenths. Okay, that was easy enough. How about this 275 and a half? Well, we know that 275 is ones, 275 ones, so we could put that first. What about the half? What is that as a decimal? Again, the easiest way to turn a fraction into a decimal is to make that denominator a tenth or a hundredth or a thousandth. So how can we make a half a tenth? We would multiply that half by 5 over 5, and that would give us 5 tenths. And I can write it like this, 5 tenths, 5 in the tenths place. Perfect. And now all we have left to do is to subtract. But before we actually do the subtraction, let's do the other way of solving this, which is taking those mixed numbers and turning them into improper fractions. To make a mixed number improper, or to make it all just one big fraction, I need to see what the denominator is, and I'm dealing with fifths, right? 426 and 1/5. So how do I turn 426 into fifths? Oh, I'm going to multiply it by 5 over 5. That'll give me fifths in my denominator. So 426 times 5 is something, and now that it's in fifths, I can add it to my 1/5. Well, 426 times 5 is 2,130 fifths, and now I have that 1/5, and I put them together, and we have 2,131 fifths. Oh, whew! Okay, now let's deal with the 275 and a half. How do we turn that into an improper fraction? Well, what are we dealing with? We're dealing with halves, so 275 as halves means I would have to multiply it by 2 over 2. So 275 times 2 over 2 plus my 1/2 would be 550 over 2, or 550 halves plus another half would give me 551 halves. Okay, now I have to put these fractions together, but I realize I'm dealing with fifths and halves. I can't put them together like that. They both need to have the same denominator. So I'm going to choose 10. I know that 5 and 2 are factors of 10. So to make 5 into 10, I'm going to multiply it by 2. It means I got to multiply my numerator by 2. And to make my halves into tenths, I'm going to have to multiply them by 5. 2 times 5, and my numerator by 5. And after all that work is done, I'll have 4,262 tenths, take away 2,755 tenths. And then I need to turn them into decimals, and 4,262 tenths would look like this, because I'm putting all of it to where it ends in the tenths place, which is the same as saying 426 and 2 tenths. The same would be said for our 2,755 tenths, which we had as a fraction. Well, writing it as a decimal is just making sure it ends in the tenths place. So it ends up being 275 and 5 tenths. Now for the actual subtraction. Either way we did this problem, we came up with these two numbers, and we know that these are what we're going to subtract. So 426 and 2 tenths minus 275 and 5 tenths. We line them up just like our add-ins, and we make sure our tenths are with our tenths, and I subtract. What's 2 tenths take away 5? Ugh. I can't do that. I can't take 5 tenths away from 2 tenths. That's like saying take away 5 cows from 2 cows. I can't do that. But we have more tenths if we look. We actually have 62 tenths. You see that 6 and the 2? But in order for us to deal only with our tenths, we're going to take one group of 10 tenths from our ones place, and that'll be leaving them with 5 ones. And that one group of 10 tenths, we crack it open in our tenths place. And now we don't have 2 tenths, we have 12 of them. And I can take 5 tenths from 12 tenths, and we're left with 7 tenths. Okay, let's move to our ones. Can I take 5 ones away from 5 ones? Of course I can. We'll be left with nothing. And so we write that down. We have no ones. We have 0 ones left. What about our tens? Okay, we have 2 tens, and we're being told to take away 7. We can't do that. And so we need to do like we did before and move to our richer neighbor, who happens to be the hundreds place. And he has something. He has 4 hundreds. Each of those hundreds, by the way, is a group of 10 tens. So I'm going to take one of those groups and leave them with 3 because we took one away. And I'm going to crack that one group of 10 tens into my tens place. And so instead of having 2 tens, we now have 10 more, which gives us a total of 12. Can I take 7 tens away from 12 tens? Of course. And we'll be left with 5 tens. Okay, all we have left is our hundreds, it looks like. We have 3 hundreds, and we're being asked to take away 2. We can do that. We'll be left with 100. Okay, 426 and 2 tenths take away 275 and 5 tenths equals 150 and 7 tenths. Okay, Sam and her friend are going on a road trip. This trip is 245 and 7/50 miles long. So they've already driven 128 and 53 hundredths of a mile. So the question is, how much further do they have to drive? Remember, here's our data. The total trip is going to be 245 and 7/50 miles. They have already traveled 128 and 53 hundredths miles. How do we find out what's left? Yeah, we're going to subtract. And so our problem looks like this. Notice that we have 2 mixed numbers that we're dealing with. Again, it's your choice. You can change these mixed numbers into improper fractions, or you can change them into decimals. I'm going to work on changing these to decimals and see how that goes for me. So, let's deal with the first mixed number, 245 and 7/50. Okay, so as a decimal, I need my fraction to end with tenths or hundredths or thousands or something. So how do I make 50ths be thousands or hundredths? Well, I know that 50 times 2 is going to give me 100, so that would be perfect. I'm going to multiply that 7/50 by 2 over 2, and I'll end up with 14 hundredths, which is perfect because I know what that looks like as a decimal. So 245 and 14 hundredths looks like 245 and 14 ending in the hundredths place. There we go. Okay, so my other mixed number was 128 and 53 hundredths. So how do I write this as a decimal? Hey, it's already in hundredths. Perfect. I have 128 and 53 hundredths. And so I put them together, and I have 128 and 53 hundredths, where 53 ends in the hundredths place. And now I subtract, making sure that I'm lining up my hundredths with my hundredths, tenths with tenths, ones with ones, and so on. Okay, Ben, he needs to replace 2 sides of his fence. One side of his fence is 367 and 9/100 meters long. The other side is 329 and 3/10 meters long. How much fence does Ben need to buy? Well, we know the lengths of both sides of the fence, and so we know we should put them together to find out how much total fence he needs. And putting them together means adding, and so our problem looks like this. And so again, I'm going to change these into decimals because look at that, it's already in hundredths. This is perfect. 367 and 9 hundredths as a decimal looks like 367 and 9 in the hundredths place. And how about this one? 329 and 3 tenths. Hey, it's in tenths. Perfect. I can write that as a decimal. 329 and 3 tenths, where 3 ends in the tenths place. And now to add, I make sure I line up my place values and I add them, and you figure out how much fence he needs. Now Mike, he wants to paint his new office with 2 different types of color. If he needs 4 4/5 gallons of red paint and 3 1/10 gallons of brown paint, how much paint does he need altogether? Oh yeah, we have 2 paints and we are going to put those gallons together. That's adding, so 4 4/5 plus 3 1/10. For this problem, let me try the other way, where we take mixed numbers and turn them into improper fraction. Let's see how that goes. Okay, so 4 4/5. What is that as an improper fraction? Well, we're dealing with fifths, so how do I make 4 whole into fifths? I'm going to multiply it by 5 over 5, and that'll give me 20 fifths. And I had 3 whole, and I wanted to make it tenths, and so I multiplied my 3 whole by 10 over 10 and got 30 tenths, as you can see on the right. Then I put those fifths together, I put those tenths together, and then, I can't put these fifths and these tenths together because their denominator's different. So I can make my fifths be tenths by multiplying them by 2 over 2, so I'll do that. And now I have tenths plus tenths. I can do that. And I end up with 79 tenths, which is the same as saying, in decimal, 79 tenths. Notice you can still see that 79 and it ends in the tenths place. So this number you can actually read many different ways. It's, yes, 7 and 9 tenths, but it's also 79 tenths. And so to sum up today's lesson, I would say that today we've learned that we need to be wise with the methods that we choose when we're dealing with mixed numbers. We can change them to improper, we can change them to decimals, and it might change on the circumstances or the problems that come to you. But now you have the tools to make the right decision.